Hi guys, so today we'll start with the examples on addition of vectors, multiplication of a vector by a scalar, then collinear condition as well as components of a vectors. Okay, so first example, I'll just take it from the worked example. Find the values of x, y, z so that the vector A is xi plus 2j plus zk and vector B is 2i plus yj plus k are equal. So question is like, we need to find x, y, z so that two vectors are given and those two vectors are equal. So as we know that if two vectors are equal, then their corresponding components are equal. Okay, is nothing bad. So component of I, the coefficient of I component in a vector and the coefficient of I component in a B vector, these two are equal. This is what the condition for two vectors are equal. Okay, should remember that if two vectors are equal, then the corresponding components are equal in both the vectors. So with the help of that condition, okay, I'll just mention it. Note that two vectors are equal if and only if their corresponding components are equal. Okay, this is what the condition. With the help of this condition, I can write that a given A vector and a B vector will be equal if and only if x is equal to 2, y is equal to 2, z is equal to 1. Okay, hope you guys understood this. So I said that these two vectors are equal. That means their corresponding components of I, j, k are equal in these two vectors. So if you compare these two vectors, the coefficient of I component in A vector is a x. The coefficient of I component in B vector is a 2. So coefficient of I, j, k components are equal in both the vectors. This is what the note. Therefore, the value of a x is a 2, value of a y is a 2 and value of a z is a 1. If nothing is there means the coefficient will be 1. Therefore, x value is a 2, y value is a 2, then z value is a 1. So this is what the x, y, z values. Okay. So next example is let vector A is I component plus 2j and vector B is 2i plus j is a magnitude of vector A is equal to magnitude of vector B? Question mark. Are the vectors A and B equal? Question mark. So here given two vectors A and B. We need to find the magnitude of both the vectors. Okay. Then we need to check whether those two are equal or not. Okay. Again, are the two vectors A and B are equal or not? We need to check. Okay. First, I'll just go with the magnitude. A magnitude of vector A is nothing but which is a square root of x square plus y square plus z square. Hope you guys remember this. X, y, z is nothing but coefficient of I, j, k component in this vector. Okay. So now the square root of, in a vector A, I coefficient is a 1. So x value is a 1 square plus j coefficient is a 2, is nothing but y value, and there is no k component, therefore z value is a 0. Hence we can write this value as 1 square is a 1, 2 square is a 4. Therefore magnitude of vector A is square root of 5. Okay. Similarly, the magnitude of vector B is square root of x is nothing but coefficient of I. So coefficient of I is a 2. Therefore 2 square plus 1 square. There is no k component, hence 0. This one is again a 4 plus 1. Even the value of this is also a 5. So if you compare the magnitude of A and magnitude of B, both are equal. So magnitude of vector A is equal with magnitude of vector B. So this is the answer for the first question. But we need to check that whether these two vectors are equal or not. Equal means you need to compare with coefficient of I, j, k, not with the magnitude. Magnitude are equal, but the coefficient of I, j, k in these two components are not equal, because I component coefficient is a 1 in vector A and I component coefficient is a 2 in vector B, and these two are not equal, right? Therefore A and B are not equal. But two vectors are not equal since their corresponding components are distinct. Okay. So I'll just go with the next one. So 1 mark question. They may ask like this. Find the unit vector. Find unit vector in the direction of vector A is 2i plus 3j plus k. If the question is find the unit vector for a vector or whatever it is in a direction, so we need to go with a definition. Unit vector is denoted by a cap, which is equal to given vector A divided by magnitude of the same vector. So this is what the definition for the unit vector. So now we just find out the magnitude first. Magnitude of vector A is, which is a square root of x square, y square, z square. X is nothing but coefficient of I, Y is coefficient of J, and Z is coefficient of a K. X square, that is a 2 square, next 3 square and 1 square, and this is of 4 plus 9 plus 1, as this is 14. Okay, therefore a unit vector A cap, which is equal to 2I plus 3J plus K, whole thing divided by square root of 14. Or else you can split it and write this is 2 divided by root 14 I cap plus 3 divided by root 14 J cap plus 1 divided by root 14 K cap. So this is what the unit vector for a given direction of a vector A. Okay. So next is find the unit vector in the direction of the sum of the vectors A is equal to 2I plus 2J minus 5K, and B is 2I plus J plus 3K. So we need to find the unit vector for a sum of these two vectors. First you need to find the sum of these two. For that resultant vector you need to find the unit vector. Okay, so I'll just take it, let sum of these two, vector A plus vector B, I'll just take it as the another vector C. Okay, so this unit vector we need to find. So before that you have to take a sum of these two. Is nothing but 2I plus 2J minus 5K, this is vector A, plus 2I plus J plus 3K, this is a vector B, as a C. So sum is nothing but you need to add the coefficient of I component separately, J component separately, and K component separately. So I can write that is a 2 plus 2 I component, okay, plus here 2 and here 1 J component, plus of minus 5 in this, and here plus 3 K component is equal to C. Okay, 2 plus 2 is 4. 4I plus 2 plus 1 is 3J. Next is minus 5 plus 3 is minus 2 K cap, which is equal to C. So this is what we got it for the sum of given two vectors. Now for this you need to find the unit vector, that is C cap, which is equal to C vector divided by magnitude of a C vector. So first find out the magnitude of a C vector, and this is equal to a square root of I component coefficient is 4, therefore 4 square plus 3 square plus minus 2 whole square, and this is of 4 square is a 16 plus 3 square is a 9 and minus 2 square is a plus 4. Don't write it minus 4, it is a plus 4 only. So 16 plus 4 is 20, 20 plus 9 is 29, therefore this is root 29. This is a magnitude of given two vector sum. Hence, unit vector of a given two vector sum is C vector divided by magnitude of C vector, which is of 4I plus 3J minus 2k divided by square root of 29, or else you can write this as 4 divided by root 29I plus 3 divided by root 29j minus 2 divided by root 29k. This is what the unit vector of given two vector sum. Hope you guys understood this. Okay, so we'll just start with the next class by the concept vector joining 2 points. And the last point, that I send the notes on these concept. So what you will do is, even I send the notes for the next concept also, that is vector joining at 2 points, a section formula also. So what you will do is, once you complete the section formula and all, you just start with these examples. Okay, so once I complete with these examples, then we can start with the exercise problems. Okay, hope you guys understood this. Addition of a vectors, multiplication of vector by scalar, and a components of a vector. Okay, thank you guys.